Let's talk about solving radical equations. So we're going to start off with some simpler examples just so we can get some of the fundamentals down, and then we'll build into some more complicated examples. The first one, square root of 2x minus 1 equals 3. Most people's instinct would be to square both sides, and that is true. But just to make a point, we are going to look at a method that a couple people threw out on the quiz recently. So there were a couple of people that said, I'm going to multiply the left side of this by 2x minus 1, which is a great thought as far as the left side. But the minute that you multiply the right side also by the square root of 2x minus 1, what you'll find is that you are eliminating one radical just to, I guess, introduce another one. So squaring both sides is going to be our best bet as far as solving this. Now, keeping in mind that what this actually means, when you square something, it means that you have that value times itself. So if we're looking at the left side of this equation, if we square that, what it actually means is the square root of 2x minus 1 times the square root of 2x minus 1. And on the right side, if we're squaring that, what that actually means is 3 times 3. This is going to come up in some of the complicated examples later, that it's really important that you remember what it means to square a side of an equation. But in this case, if we square the left side, we are going to get 2x minus 1, and if we square the right side, we're going to get 9. Now, in terms of solving a radical equation, what we are looking for is what x value is going to allow us to obtain a real number answer. So in terms of a square root, what that means is that the radicand value underneath cannot be negative, because the square root of a negative will be imaginary. But if you look at what just happened, when we squared both sides, we are now looking at a linear equation. 2x minus 1 equals 9 is linear. There are no restrictions on a linear equation. So what that means is x in a linear can be positive, negative, 0. It doesn't matter. So solving this really quick, this linear equation is going to give us that x equals 5. Obviously, that's going to work in 2x minus 1 equals 9. The question is, does it work in the original? So you need to take this, and you do need to double check that it works in the original equation and that it's not extraneous. So if you plug this back in, you are going to get 2 times the square root of 2 times 5 minus 1. Is that equal to 3? Well, you get the square root of 9. Is that equal to 3? 3 does equal 3, therefore it works. Remember that when you are taking the square root of a number in terms of a radical equation, the radical was already there. So we are going to treat this as if it is a function. And so what that means is if you put one number in, you can only get one number out. And as far as the number out of a square root, we're going to deal with the primary solution, which is always the positive. So the square root of 9 in this case is 3. We're not recognizing negative 3 as an option. So what that means for this particular equation is that x does equal 5. Now, the next one, you could square it as is, and what you would find is that you're not going to get very far. It would also be much easier, and I think most of you will agree, is if you isolate the radical. That means now you have one term on one side of the equation and the other term on the other side of the equation. This makes squaring much easier. So if you square the left and you square the right, you will end up with that 3x equals 36, which means that x equals 12. Now again, we went from a radical to a linear, and the solution to the linear is 12. You do need to make sure that that works if you plug it back in. So if you look at your original, the question is, does the square root of 3 times 12 plus 6 equal 0? Well, 3 times 12 is 36 plus 6. The square root of 36 is 6. Does 6 plus 6 equal 0? The answer is no. So what that actually means is that this equation does not have a solution because there's no x value that will work in the original. I'm going to make an argument that you would actually know from this step that you don't have a solution to this equation. If you think back to what we started with here, we had the square root of 3x is equal to negative 6. You would also know that if you plug a number in for x, multiply it by 3 and take the square root, the outcome of that is going to be positive because the square root of anything in terms of a function is positive. A positive number will never equal -6. Therefore, there is no value for x that is going to make that equation work. If you happen to catch that early on, you are welcome to make the statement that you know that this equation does not have a solution. However, if you are a person who is going to solve all the way out, you do need to get into the habit of making sure that the answer you come up with works if you plug it back into your original. One more somewhat simple example, we're going to deal a little bit with cube roots. So just like a square root, to undo it, you square it. A cube root, you're going to cube it in order to undo what's happening. Keeping in mind, a cube root does not have the same restrictions as a square root. The radicand value in a cube root can be positive, negative, or 0. So there's no restriction on a cube root, but I would recommend checking your answers anyway. So if you cube both sides of this, you are going to get x minus 5, and you are going to get 2x plus 3. Solving this is going to give you that x equals -8. Now, because there's no restriction, this answer is probably right. However, I would plug it in just to make sure that you mathed correctly. So if I plug -8 in, I want to make sure that I get the same value on both sides. So on the left, -8 minus 5 is -13. On the right, 2 times -8 plus 3 is also -13. Does the cube root of -13 exist? Yes, it is a real number. Is it a nice number? No, but that's not super important. The important part is that it is a real number solution. Therefore, -8 does work, and we have correctly solved for x. Now, moving into some examples that might start catching a few of you off guard. The first one we're going to look at is the square root of x plus 2 is equal to x. Now, a couple of different methods that you can use, but I'm going to show you the one that will work for more complicated versions as well. You can square this right now if you wanted, but again, I think the past 3 examples have shown that it's a lot easier to square if the radical is by itself. So if possible, I would isolate the radical. And in this case, that is. So I'm going to move the 2 over. And what that allows me to do now is just square a square root all by itself, which is going to give me the square root of x times the square root of x, which is going to give me x. And then I'm going to square the right side. Well, the right side, I'm squaring the entire side of the equation. So x minus 2 squared is x minus 2 times x minus 2. If you are going to goof a step, I would be willing to bet that this is going to be it. And I say that because the temptation is that x minus 2 squared is going to give me x squared plus 4, because people want to just take the exponent and distribute it through. That is not going to be an option. Recognizing that you know what it means to square the side of the equation, it means to take that and multiply it by itself. So x minus 2 squared is not x squared plus 4. It is x squared minus 4x plus 4. Noticing now that we have a quadratic equation, you would know that the easiest way to solve a quadratic is to make it equal 0. So I'm going to bring that x over. You would also know that my first inclination is to see if that factors. And it does, and I'm going to get x minus 4x minus 1, and what that means is that x could be 4 or x can be 1. Now those solutions came from a quadratic. We need to make sure that they work in our original. So I'm going to plug 4 in and ask, does the square root of 4 plus 2 equal 4? The answer is yes, because I'm going to get 2 plus 2. That does equal 4. And I'm going to plug 1 in. So the question is, does the square root of 1 plus 2 equal 1? Well, does 1 plus 2 equal 1? The answer is no. So the only actual solution that works in this case is that x equals 4. 1 would work if we were recognizing the negative option to that problem. We are not. We are only recognizing the primary solution. So therefore, the only solution for x is 4. Now, using that thought of wanting to isolate the radical, let's talk about a more complicated example. So we have the square root of 3x minus 5 plus the square root of x minus 1 is equal to 2. There are technically two different approaches. You will find that they are the same number of steps within a couple, and that the steps themselves are very similar. It's just all of the things that happen in those steps that are going to be different. So I'm going to do this both ways just so that you can see that the answer ends up being the same. But I do want you to see how what we've talked about with radicals is going to come into play, but it comes in slightly different in both. So the first way I'm going to do this is I am actually going to leave it the way that it's written, and I am just going to go ahead and square it now. So because there's no way to isolate a radical, or both of them. I can't isolate both at once. So I'm going to leave it, and I'm going to go ahead and square both sides. So if I square the left, what that means is that I have the square root of 3x plus 5 plus the square root of x minus 1 times itself. And that's going to equal 4. I'm just going to go ahead and square the right side of that really quick. And we've got some distribution to do. And this is what makes this particular method a little bit intimidating, but it's really not that bad because you all know how to multiply radicals. So I'm going to distribute. So I get the square root of 3x minus 5 times the square root of 3x minus 5. That's just 3x minus 5. Then I have the square root of 3x minus 5 times the square root of x minus 1. Well, they're both square roots, so I can multiply what's underneath. And for now, I'm just going to leave it. Then I'm going to do my insides, which is actually going to give me the exact same thing. And you'll notice that that will be a pattern. And then I'm going to do the last two. So the square root of x minus 1 times the square root of x minus 1 is just x minus 1. So that's a pretty long looking equation, but I do have some like terms that can be combined. So I have a 3x and an x, that's going to give me a 4x. I have a negative 5 and a negative 1, that's going to give me a negative 6. And I've got two of the same radical, which means that I can essentially add them together. And that's all going to equal 4. Now, even though this is a slightly more complex example, it's very similar to the one that we just did. Notice there's only one radical left. So it'd be really nice if I could isolate that, and I can. You will also notice that because I have one radical left, I am going to have to square this again. And that should make sense because look back at the original problem. There are two radicals and they are different. So there's no way to multiply to cancel them both out at once. So I'm going to have to do this in 2 steps. So to isolate the radical, I'm going to move the 4x and that negative 6 to the other side. So I'm going to have negative 4x plus 10. Now, you will also notice, maybe, that all 3 of these terms are divisible by 2. That's not a requirement, but I'm a fan of keeping numbers smaller if possible, so I'm going to go ahead and divide this entire equation by 2. What that will do for me right now is it will leave me with the radical by itself on one side, and on the other, it's going to give me negative 2x plus 5. So now I'm down to the exact same spot where I was in my previous problem of where I started that one. So I have a radical on one side and all the other terms on the other. I am now in a position that I can square both sides. So squaring the right side is going to give me 3x minus 5 times x minus 1 because the radical cancels. And remember, squaring the right side of this means that you are multiplying the entire thing by itself. So notice on both sides of the equation, I have 2 factors multiplied together. I'm going to have to FOIL both of them. So why not just go ahead and do all of that now? Some of you, if you choose to do it this way, you might have chosen to FOIL what's on the left earlier in the problem. Totally up to you. It really doesn't matter. So this is going to give me 3x squared minus 3x minus 5x plus 5. Is equal to 4x squared minus 10x plus 25. I'm going to go ahead and combine separately. So this is going to give me 3x squared minus 8x plus 5. And on the right, I'm going to get 4x squared minus 20x plus 25. Noticing that all this is just a quadratic, again, I'm going to want to make this equal 0 if possible. So I'm going to squeeze this up here. I'm going to subtract the 3x squared over, so that will give me x squared. I'm going to add the 8x, so that's going to give me negative 12. And I'm going to subtract the 5, which will give me 20. This factors, so I'm going to get x minus 10 times x minus 2. Therefore, x equals 10 or 2. I am going to want to check both of them just to be sure, because those came out of a quadratic. My original equation had square roots. So checking 10, 3 times 10 is 30, minus 5 is 25, plus the square root of 10 minus 1. Does that equal 2? The answer is no. So checking 2, 3 times 2 is 6, minus 1 is 5, plus the square root of 2 minus 1. Does that equal 2? The answer is yes. So in this case, the only valid solution that we just came up with is that x equals 2. It is possible for both of them to work. It is possible that only one of them works, and it is possible that neither of them work. So do pay attention to that as you move through this section. So let's look at the exact same problem, but I'm going to switch up how I do this. You will notice that the steps are about the same in number, but they come across a little bit simpler in this, I think anyway, in this one. I'm going to split the radicals. So I'm going to leave one of them, I'm going to isolate one, and I'm going to move the other. I tend to isolate the one that seems the most complicated. So of the two, I think that 3x minus 5 is a more complicated radical than x minus 1. So I'm going to leave the 3x minus 5 by itself, and I'm going to subtract the x minus 1 over. What this does, in my opinion, is it just makes the squaring step a lot easier, particularly this one. So I am going to go ahead and square both sides because I have a radical by itself. So squaring the left is going to give me 3x minus 5. Squaring the right means, again, that you have the entire side times itself. So if you distribute that out, 2 times 2 is 4, 2 times the radical, and it's negative, and then 2 times the other radical, also negative. Now, you know that the square root of x minus 1 times the square root of x minus 1 is x minus 1, but notice that they're both negative, so when you multiply them together, it is going to create a positive x minus 1. Again, I would go ahead and combine some like terms. So I've got 4 and a negative 1, which will be 3, plus x, and then minus 4 square roots of x minus 1. Noticing that I only have one radical left, I would move the other stuff over. So I'm going to subtract the x, and I'm going to subtract the 3. And that's going to leave me with just negative 4 times the square root of x minus 1. Again, I happen to notice that all three of those terms are pretty easily divisible by 2. And the only benefit to that is it's going to keep numbers small. You could divide by negative 2 if you want, but knowing that I'm squaring it, I don't mind if the negative is here, because the minute I square it, it is going to become positive. I do have the radical isolated, so I'm going to go ahead and square everything. X minus 4 squared is x squared minus 8x plus 16. And remember, when you square the right side of this, you have to square everything. So the negative 2 gets squared and the radical gets squared. And remember, I'm not foiling this side because this operation is multiplication. I am allowed to distribute an exponent across multiplication. Simplifying this a little bit is going to give me the quadratic on one side and 4x minus 4 on the other. Again, it's a quadratic, so I'm going to make everything equal 0. Subtract the 4x, add the 4. You will notice this is the same quadratic we came up with in the previous method. It factors the exact same way, leaving me with the exact same x values, and again, checking both of them. The only one that is going to work is x equals 2. So keep in mind what it means to square a side of an equation. Keep in mind everything that you know about combining radicals. You have an assignment that goes along with this. If you come up with questions, shoot me an email, and have a great rest of your day.